This will be a bit long of a lecture for completing the square, but I want to make sure that everyone has a good understanding of the completing the square. So I want to start out by pointing out that the squaring of binomial is not so straightforward. So here's x plus 1 squared. If you square x plus 1, you're going to get x squared, so you get x squared, and you also get 1 squared. But something else happens. You have one more term. Do you know what this one is? 2x. Very good. So those of you who have strong algebra foundation will know that there should be a 2x. But those of you who are not so sure where this came from, so let me do a brief explanation. Last time I showed you that if you FOIL this out, you know what FOIL is, right? First, outer, inner, last, right? It's FOIL, first, outer, inner, last. And AX times CX gives you AX squared, no, ACX squared. AX times CX gives you ACX squared. And then if you multiply the last, so F gives you this one. If you multiply the two lasts, so B is the last of these two and D is the last of these two. If you multiply, you get BD. So that comes from this L. However, the outer creates ADX and the inner creates BCX. And these are like terms, so you can factor the x out, which gives you this middle term, which is AD plus BCX. I need some more room. Let me just erase this. So you get AD plus BCX plus BD. Okay? So you should visualize like this. The first term is the F. The middle term is really the outer and inner combined. Those two things get added up. And the last one is the two last ones multiplies, B times C. Yes?
You just wrote it as x squared plus 2x plus 1. Would it be wrong?
Oh, yeah, this should be fine. I was just trying to make a point that there's this extra thing. That was all. Okay, so if you go back to this question, you can explain why you get the 2x from here. X plus 1 squared means anything squared is you multiply it by itself, right? Oh, then this is like indeed product of two things that look like that, right? You FOILed it out, right? And what did we just learn? First, x is the first, x times x, that gives you x squared. Last, 1 is the last here, 1 is the last here. If you multiply them, what do you get? 1. But there, it creates something in between, right? There's the outer and the inner. What is the outer? X times 1 is? X. 1 times x is? If you add the 2, what do you get? 2x. That's where the 2x comes from, okay? You have to know that it's first and the last, this middle one, which is also known as the cross terms. We sometimes say this is the cross terms. The cross terms create this middle one, which is a bit strange if you didn't know. If you saw this for the first time, you would understand that, oh, I see x squared, that makes sense. 1, that makes sense. But the moment somebody says there's also 2x, it's like, what? Where did that come from, right? So that's the mysterious thing. Okay, now let me point out something more about this. In math, you might have a single symbol, but the meaning of it might be different depending on the context. Just like in English, you have a word, and the word might have different meanings in different contexts. Like apple could be a computer, or it could also be something you can eat, right? So this equal sign here is a bit different from, say, 3x is equal to 12. Now, this 3x equals to 12 can be solved. What's the answer? You divide both sides by 3 and you get x equals to 4. which means that this equal sign right here is not always true. When is it true? It's true only when x is 4. Whereas this equal sign is always true. It doesn't care if x is 1 or 2 or 3. You just plug in the same values left and right. You'll see that they're always, these two sides are always true. Okay? So we say that this equation is a conditional equation, whereas this equation is an identity. Okay? Well, we just say this is an equation that's an identity. Okay? There's a distinction between the two. Okay? Now, if you know the distinction, then you can use this in several different ways. So, I tend to stress mental math a lot, so let me give you a mental math challenge. What is 101 squared mentally? Would you be able to do this mentally? Well, of course, it'll be hard. Can you do it? Can anyone do it? Okay. You want to try? What is it? Huh?
202.
No, that would be 101 times 2. This is 101 times 101, right? So this is like 100 plus 1 squared.
1,102.
Sorry, none of them are right. Okay, so what you're going to do is you're going to say 101 is same as 100 plus 1. Isn't that right? And then look at this, and we just learned how to do this one, right? So according to this identity, what is this equal to? 100 squared plus 2 times 100 plus 1, which is 10,200 plus 1, which is 10,201. You get that? Okay? Yeah. So I think there's a general disconnect between what you get out of algebra and what it means for actual numbers. If something is true as an identity, that means it should be true whatever number you plug in. It's always true. Okay? So let me do another similar thing. Suppose you have x plus 3 squared. Let's try this one. X plus 3 squared. Now x plus 3 squared means you have x plus 3 times x plus 3. If you expand this, what's going to happen? The first will create x squared. The two last is going to create 9. 3 times 3 is 9, right? But then there's something in between. What is that? You get outer, which is 3x. You get inner, which is 3x. If you add the 2, what do you get? 6x. So 6x will be here. Now, just by looking at these two examples, you already find the pattern. What's the pattern? The middle one is what? Twice of this number, right? Where are we getting this 6 from? It's twice of this number. You see that? Twice of 3 will be 6. Okay. So you can also do other things like, say if you had x plus 2 squared, what would that be? X squared plus 4x plus 4. That's what's going to happen. Okay? Because the O and I adds up for the square case, it's the same thing, so you end up just doubling. Okay? So that's what's happening. All right. So since you now know this identity, let me give you another challenge in mental math. What is 103 squared? Let me see if you can do this challenge. You can do this. 609. Yeah. Yeah, because 9 is added, right? Good? You get that? Yeah. What about 13 squared? 169. 169. 169. Same stuff. Right? Okay? How about 1.03 squared? Same story as this one, except that you have some decimals. What is it? 1.0609. See, you're multiplying two numbers that are very close to 1, so the outcome should also be something close to 1. Right? Because 1 times 1 is 1. But it should be slightly bigger than 1, which is 1.0609. What about 1.01 squared? 1.0201. Yeah. It's fun, right? No, it is. It is fun. You know, as a mathematician, when I go to parties, I do these things. I eat nice food and enjoy the music, and suddenly ask, hey, give me two-digit numbers. Let me multiply for you, and then people enjoy it. Yeah, it's fun. Okay. Yeah. So one thing you could do is like if you go home for Thanksgiving dinner, while eating Thanksgiving dinner, Mom, you know what 101 squared is? Yeah, you can impress your parents. They're going to be proud that they sent you to college, right? Yeah. All right, you have a question?
Yeah, do you ever play your like quadratic equation song at parties?
No, I should do that next time. Yeah, that's good. All right. Okay, so now let's talk about complete. Yes.
Could you do the ax plus b multiplied by cx plus d? I don't see how like the middle term where it's ad plus
Oh,
bc,
okay. So
where the x
you're
plus
asking. We want to review this result, right?
Yeah.
Cx plus. All right. So first, a times c times x times x. So you get x squared, right? So you get a c x squared.
Yeah.
And then outer ax times d, so it's a dx. Multiplication is commutative, so you want to write down x at the last. So it's a dx. And then b times cx, what's that? bcx. And last, which is bd. Okay, now what you do is these two middle terms, these are numbers, so these are like terms. So you can factor the x out. You're yanking out the x. What are the people that are left behind? AD plus BC. Okay? So that's why we get this identity. So the outer and the inner adds up, and because of that, when it's something x plus a squared, you get x squared twice of a, and then you get this squared. That's that's how you do the square of a binomial. All right, now let's try to use this to solve a question. So suppose you're given this example problem. Let's say you have x squared plus 4x minus 2 equals to 0. How do you solve this? Well, what you do is first, sorry, let me make this into 6. I like 6 better. Sorry about that. So suppose you have x squared plus 6x minus 2. How do you solve this? Well, let me give you two solutions because it's more, you understand better if you do it in two different ways, okay? Please be quiet. I'm recording it, so you don't want your words to be near. Yeah. There's some weird guys in the internet that follows you. Yeah. You don't want to do that. All right. Okay. So back to this. I want to show you two different methods. What is you have this minus 2, you move it to the other side. So you get x squared plus 6x equals to 2. Oh, no, not that. That's not the first method. Okay. Let me do this again. Yeah. So if you have x squared plus 6x minus 2 equals to 0, let me show you two different ways to solve this. One is the quadratic formula. Can you sing the quadratic formula? X equals to negative b plus or minus square root b squared minus 4ac all over 2a. Very good. And what is a? A is the coefficient of x squared, which is 1. B is? C is? Negative 2. Very good. So you're going to write down negative b, which is negative 6, plus or minus, and then 6 squared. What's 6 squared? 36. Minus 4 times a is 1. C is negative 2. Okay. And then you have twice of 1. And then, let's see, you have negative 6 plus minus. Negative is positive, so it's plus 8. 8 plus 36 gives you, what is it? 44, square root of 44, right? Over 2. However, if you stop here, I cannot give you full credit because you have to simplify further. So let me show you how to simplify this further. See, 44 is 4 times 11, right? Square root of 44 is 4 times 11 inside the square root. And if you have a square factor inside the square root, that can come out, that can escape the square root as what? 2. Since the square root of 4 is 2, it comes out as 2. So this becomes 2 times square root of 11. Okay? And using that, now you have negative 6 plus minus 2 times square root of 11 over 2. And now you divide both of them by 2. So 6 divided by 2 is 3. And 2 divided by 2 is 1, so it's gone, and you just have plus or minus square root of 11. Okay, so that's the answer. That's method 1. Now let me show you the second method. Solution 2. And this is the completing the square method. Everything until here was a preamble. I was just trying to lead you gently into this thing, because if you just see it for the first time, it's confusing. All right, so step 1 is this. You want to move this number to the other side. You write it like this, and you need a space between. So move that constant term to the other side. If this was a plus 2, then it would go to the other side as a minus 2. The sign changes, right? So you do this, and now you ask, what should I put here so that the entire left side becomes a square? And that's where this name completing the square comes from. Okay? Completing the square, the name comes from the fact that you're putting something so that the entire thing becomes a square. Make sense? Okay? But then, because I know that x squared is created by squaring the x, and this one is twice of something here. What should go in here? 3. So you can first foresee, you have to kind of be a fortune teller. You have to predict the future. Okay? So I'm going to be putting something here, and if you do that, the number that you'll end up putting here will be 3. And it's obviously true, because whatever this is, the twice of that number is this. Okay? Another way to think about it is you just take the half of this 6 and you get 3. That's quicker, right? Take the half. But then, if that's true, what is this one? 3 squared is 9, so this must be 9. But whatever you do, on the left side, you have to treat both sides fairly, right? So if you're going to put a 9 here, you better put the same thing over here. So to get this, what you end up with is you have to do x squared plus 6x plus 9, and then plus 9. So we're adding 9 both sides. The left side becomes x plus 3 squared. And if you don't trust yourself, sometimes you do calculations that you want to make sure, right? In that case, just expand and see if it makes sense. X squared gives you x squared, 3 squared gives you 9, and you double the product, right? Twice of 3x would be 6x, so everything's perfect. The left side is same. What about the right side? 2 plus 9 is 11. Okay? And now we're just a few steps away from getting the answer, because you just have to remove the 2. What happens? How do you remove the square? Take the square root. It removes the square, right? We take the square root. Now, is this right? You're forgetting something. What are we forgetting? Whenever you take the square root, you must put plus or minus. Okay? It's something that you learned a long time ago. Don't forget that. Whenever you take the square root, you have to put plus or minus. And then finally, the answer is you subtract 3 both sides, and you get x equals to negative 3 plus or minus square root of 11. Yes?
You know where I get the
9? Oh, yeah, I will. Just a minute. Let me compare these two answers. Are they the same? Two methods gave us the exact same answer. That's good, okay? Because math should always give you the same answer regardless of the method you do. Okay, I got a request of where I'm getting this one from is, first you take half of 6 and you get 3, and then the moment you choose 3, now you need 3 squared to become the square, right? So 3 squared is this 9. That's where it comes from.
So whatever half of b, like the b value is,
Mhm.
squared is gonna be what the c value is.
Yes, yes, that's what you do. Okay. Now, hopefully, you didn't memorize that. One of the big problems of people studying in math is that you tend to overestimate your ability to memorize and underestimate your ability to understand. Keep that in mind. Most of you do that. Okay? You overestimate your ability to memorize. You think you have perfect memory for some reason. I don't. And somehow everyone thinks they have perfect memory. And then you underestimate how much you can understand. Yeah, you think, oh, math is as hard as something that it's impossible to understand. I'll just memorize everything. Now, guess what happens? If you memorize everything, at that moment you might think that you're understanding it, but the next day when you return and try to do another set of problems, you don't remember a thing because you didn't understand the thing. Okay? So you have to change the way you do math. Did you notice that I come to this room every time without any notes? I just write everything on the board and just start speaking, right? Yeah, I do that for all my classes. I just wake up. Okay, so what am I going to teach today? I'll just think of some examples. Okay, that's good. I just come here. Yeah. Does that mean I memorize all the examples and solutions? No, I don't. It's just natural. It's obviously this. What else can it be? Anytime I write something, it has to be this example. It's obvious. You can even kidnap me, put me in an island, and ask me to write a textbook for pre-calculus, calculus 1, 2, and 3, and differential equations. I can do it for $1 million. But, but the point is, all these things are not in my head as a memorized thing. It just makes sense because I understand everything. If you understand everything, that's the easiest way to do the math. The reason that you're struggling is because you started out by, at some point, thinking, oh, this is too hard, I'll just memorize. Then what you end up with working with is you have this knowledge debt. You end up with the knowledge debt. And it just accumulates. The next time you try to learn something, because you don't know this, you can't understand the next thing. And it just accumulates, and the only way you can pass a math course is if you have a photographic memory, you might be able to pass. But not many people have that. Does anyone have such a thing in this room? I don't see anyone raising their hand. So that means nobody has photographic memory. That means you better try to understand. And it's better now than never. When you can try to understand, make it make sense to you, and then a lot of times you'll be able to understand it. Okay?